Hi everyone, welcome to week 5. This is where we'll start talking about dosage calculations. Our reading for week 5 is from page 881 in your textbook until page 886. Dosage calculations are really important. In order to give the patient the right dose, the right route, at the right time, you need to know how to do dosage calculations. Ooh, Jesus. So we're going to start by talking about those for chapter 5, and then I think in the second part is where we actually learn how to calculate. To properly prepare a medication, a medical assistant must be able to read and comprehend a physician's order, read and comprehend the medication label, calculate an appropriate dose, educate patients on how to take the medication, and assist patients with understanding warning labels. The physician is usually the healthcare team member responsible for creating medications. However, oftentimes the administration or explaining to a patient does fall down to the people such as nurses, medical assistants, pharmacists, etc. So a medication order is basically something that's written by the physician, whether it's computerized or actually on a piece of paper like an order sheet, and it should have the name of the drug administered, dispensed, or prescribed, the drug form, drug dosage, frequency of administration, and any special instructions for taking the medication. For example, let's go with Docusate is going to be the name of our drug that's going to be administered and ordered. So Docusate is going to be a capsule, that's the drug form. They are going to give you 100 milligrams of Docusate. So Docusate, 100 milligram capsule by mouth times 1. So that would be your frequency, that times 1. And maybe the doctor wants them to take it on an empty stomach, and that would be the special instructions. So let's talk about some apothecary or some math fundamentals. Where do we get our measurements from? In order to calculate medication doses, medical assistants must have an understanding of basic math principles. Some math skills that are necessary for calculating doses include the ability to form metric conversions and set up and solve equations. So there are two major systems used to calculate medication doses, the apothecary system and the metric system. The old way was the apothecary system. This is sort of the historic form of pharmacy. And it was replaced by the metric system in the first half of the 20th century. The metric system is a primary system method for measuring weight, volume, and length throughout the world. It evolved into le système, I can't even say that, I'm not French, it looks very fancy, or international system of units, basically. And it's the primary method of measurement in medicine. It's a decimal system because it's based on multiples of 10, and it can be easily converted into other units by simply moving the decimal place. So table 31-1 lists common prefixes and their standard values, so become very familiar with those. The most common ones that we're going to use are micro, milli, and kilo. So the three fundamental units used in the metric system are measure volume, length, and weight, and that would be, sorry I keep missing the slides here, that would be the meter, the liter, and the gram. So again, if you see 31-2, that table, medication doses are usually measured in grams, milligrams, micrograms, units. Volumes are measured in milliliters or cubic centimeters, however, usually more commonly mLs. Laboratory results are usually measured in milligrams, micrograms, or grams per deciliter or units per liter. Whereas we measure other things like blood pressure or like for weight for organs, we can measure that in grams, but blood pressure is actually called millimeters of mercury. The following, okay. For all units except for liters, we use lowercase letters. So for example, milligram, grams, millimeters, milliliters, and you leave a full space between a number and the unit. For international convention, no commas in long numbers, although you will commonly see them in the United States. There are other, moving on, other guidelines. The first ones that we mentioned are pretty commonly used. So avoid mixing symbols with names spelled out in the same expression. For example, 8 kg/liters means 8 kilograms per liter. So you wouldn't want to spell out liter but not kilograms. Arabic numbers are used for whole numbers, so 1, 10, 100, 1000. And fractions are converted to their decimal equivalents for quantities less than 1. So for example, 1/10 would be 0.1, 1/2 would be 0.5, and so on. A 0 should always be placed before decimal points for numbers less than 1 to avoid confusion so that you don't overdose a patient. And metric units do not have singular or plural forms. For example, 5 ml, 2 ml, 60 milligram, no S at the end. That can lead to errors. And those Arabic numbers, or numbers that we're familiar with, are always precede a metric unit of measurement. So for example, 10 grams, 2 milliliters, 5 liters. Gram is abbreviated by writing GM or a lowercase g. The preferred abbreviation is G because they have found it to be less associated with errors. When measurement symbol or a symbol is named after a person, capitalize that measurement and symbol. For example, when you measure something in degrees Celsius, it's a capital C. So conversions. Metric conversions just means to switch between one unit to another. For example, going from milliliters to liters. A good example of this might be a physician orders a drug in milligrams, but the drug label measures in grams, and you need to figure out how many grams to give to equal what the physician is asking for. So there's a number of different methods that you can use to do this. The conversion factor method. You're going to see table 31-3 for common units used in the metric system and how to convert them. The conversion factor method can be used for both performing conversions within the metric system and for performing conversions between two different systems. To perform conversions using the conversion factor method, a factor equivalent table will need to be available to use when setting up problems. So an example that they gave was 5 grams equals blank milligrams. Write down the initial measurement and place it over the number 1. You are creating a fraction. The initial measurement becomes the numerator and the 1 is the denominator. Next to this, create a second fraction. Place the number 1 beside the unit you want to convert to, in this case milligrams. This will be the numerator in the second fraction. Proceed to step 2 to add the denominator. I'm reading straight off the book and then I'm going to try to explain it a little better to you. The denominator of the second fraction is the converting factor from the appropriate factor equivalent table, i.e., if you look up at table 31-3 and we are going from grams to milligrams, for every gram you have, for every 1 milligram you have 0.001 grams. So on the bottom of that second fraction is going to be 0.001 grams. So you're going to multiply the two numerators and the two denominators. Note that the grams are in opposite position and therefore they cancel each other out. So on the top you have 5 times 1 and on the bottom you have 1 times 0.001. Now divide the numerator by the denominator and your answer is going to be 5,000 milligrams. The next method is the shortcut or counting method. Since the metric system uses multiples of 10, it is relatively easy to perform conversions within the metric system because all you are doing is moving the decimal point to a specific number of places to the right or left. So this is where table 31-4 comes in. It illustrates the common metric units used in healthcare and their values in descending order. The bottom row of the table has a counting section with arrows, and the arrows point to the metric unit that each arrow represents. This is the section used to determine how many places and in which direction to move the decimal. So let's go with the example of 1 gram equals X number of milligrams. Start by placing your finger in the box of the arrow that represents the unit of known value. In this case, we're talking about grams. Next, move your finger the number of places that it takes to get from the known value to the unknown value. In this case, we're headed to the right, and we're going to go 1, 2, 3 spots over to milligrams. Next, move the decimal place and the number of the known value of places that it took to get from the known value to the unknown value. So in this case, we went to the right, so we're going to add zeros, and we're going to add 3 of them to be exact. So 1,000 milligrams is equal to 1 gram. It gets a little trickier when you move the decimal from the right to the left. For example, converting from 5 milligrams to X number of grams. So we're going to put our finger on the milli, because we know we have 5 milligrams. Then we're going to move our finger to grams. 1, 2, 3 to the left. So we're going to add 3 decimal places. We're going to move the decimal place 3 parts, okay? So it's theoretically it would be 5.0. We're going to just get rid of that 0 because it's not really there, but we've got 5 point, right? And then we're going to move the decimal place 3 places to the left. So it'll go 0.5, 0.05, 0.005. And then to be proper, we would put a 0 in front of the decimal place. Hopefully this isn't too confusing for you guys. It gets really simple once you've done it for a while. If you ever forget though, just remember, most commonly we're converting between kilograms, milligrams, and grams. 1,000 milligrams is equal to 1 gram, and 1,000 grams is equal to 1 kilogram. So kilograms are big, grams are medium, milligrams are tiny. Okay, so last but not least, I think this is where we finish up talking about some common measurements. Actually, I think it stops. I do believe household measurements should be included in this PowerPoint. So let's just talk about them real quick. Household measurements. The imperial system, also known as the household system. Sorry, my dogs are going nuts tonight. Of measuring volume and weight can be found in any kitchen in the United States. Okay, so household measurements that you might be familiar with include the teaspoon, the tablespoon, the ounce, and the cup, pint, or quart. Table 31-5 has common household measurements and their conversions. We don't use these too often in medicine, with the exception of when we send a patient home on a medication that's liquid. And most often you will see it in the form of tablespoon or teaspoonful. So always remember, a teaspoon is 5 mLs, and a tablespoon is 15 mLs, and that's in table 31-6. They also have conversions for ounces, cups, pounds, etc. Pounds to kilogram is another very important one. Every 2.2 pounds you weigh is 1 kilogram. So if a person weighs about 150 pounds, their number gets smaller for kilograms. They're about 70 kilograms. So if you ever want to figure out your weight in kilograms, just divide your pounds by 2.2. And if you ever want to go from kilograms to pounds, which we don't really need to do very often, multiply kilograms by 2.2. Hope that wasn't too confusing for you guys. I know math can be scary for many of you. If you ever need help on math, I am more than happy to help you in any way I can. And I'm going to try to find some videos for conversion factors because I want you guys to be able to understand it. Otherwise, I'll see you guys in week 6.